Hello, I'm Paige DeVries. I'm one of the authors on this paper. The project focuses on the assessment of sign language-based versus touch-based input for deaf users interacting with intelligent personal assistants. Smart home environments are continuously becoming more popular as tech continues to develop. Popular examples include Amazon's Alexa, which we used here. Another example is Google Home. Both of these work using automatic speech recognition, ASR for short, that translates speech to text. Several past works by a variety of authors have suggested deaf interest in working with these devices, but the question remains of how. Text-to-speech, TTS for short, works, but slower, and IPAs can't understand ASL. This slide highlights the main research questions our team aimed to answer within the study. Our first research question asks, what are the perceptions and preferences of deaf users regarding sign language-based versus touchscreen-based input methods while interacting with intelligent personal assistants? Research question 2 is, what is the nature of the interaction between deaf users and IPAs within the confines of a limited domain application? The third research question for the project is, what is the range of expression and vocabulary seen among deaf users interacting with IPAs within the confines of a limited domain application? Worldwide, there are hundreds of known sign languages that serve as the primary communication method for many deaf and hard of hearing people. ASR enables IPAs to understand spoken commands, but this is much less successful for deaf accented speech, and the technology remains inaccessible to many deaf users who rely on signing for communication. Researchers are exploring a variety of methods for interaction. ASL or other sign languages, text-to-speech or TTS for short, gestures, and deaf accented speech. Several past studies highlight success using a Wizard of Oz experimental setup where a trained interpreter performs an ASL to speech function to simulate machine understanding, so we applied that format here. An interdisciplinary paper by Bragg et al., 2019, laid out key calls to action for sign language technology improvements in the future. One of those calls asked researchers to investigate the user experience, which was the main focus of our work. We have a total of 23 participants who will identify as deaf or hard of hearing, are fluent in ASL, and at least 18 years old. Most participants are between the ages of 18 and 34 years old, with some people who are older than that. 66.7% of our participants identified as white, with the remaining 33.7% identifying in a range spread across Black, Hispanic or Latino, and Asian. Almost all use ASL as their primary communication mode. Only 25% report experience with IPAs, and only half report using forms of voice control. The setup consists of two different stations: the Smart Home Dorothy station for their participant with the TV and smart lights, and the Wizard station for a hidden researcher. As you may remember, the wizard pulls the strings and Dorothy is fooled into thinking everything is real. The hidden researcher at the Wizard station supports the Wizard of Oz approach from a separate room by voicing signed ASL commands via a clandestine FaceTime link. Normally, an ASL interpreter focuses on the meaning behind the words rather than literal interpretation. But in this context, the wizard needs to be trained to produce a very literal form of interpretation in collaboration with the deaf research team who created the experimental setup. Participants complete 3 parallel smart home task lists with 3 distinct input methods: ASL to Alexa, apps with Alexa, and tap to Alexa. For ASL to Alexa, users sign to Alexa and we run through the previously described Wizard of Oz experimental setup. For apps with Alexa, they use an iPad with several apps. For tap to Alexa, they interact with the Echo Show's touchscreen using preset icons representing the task list items. We apply the System Usability Scale, or SUS for short, which provides a 5-point scale from strongly agree to strongly disagree across 10 questions and generates an aggregate score between 0 and 100. Participants were given the choice between the written English SUS or a validated ASL translation. They completed the SUS immediately after each task for a total of 3 times, and also completed a post-experiment survey that asked several questions about their experience interacting with the smart home system throughout the study. Researchers use Elan for annotating the sign language portion of the interviews. Elan is a linguistic software commonly used for analyzing ASL due to how it allows users to code language in real time. Annotated glosses for each sign reference to the sign bank database. This allows for consistently capturing different variants of the same sign in a normalized manner. Fingerspelling was annotated differently to account for the endless variations of fingerspelled words, as were gestures and pointing. The most commonly fingerspelled words we see in this project are fingerspelling TV, off, and mute, in reference to the Fire TV. This bar graph shows the mean SUS scores of each of the 3 conditions with Alexa. None of the pairwise differences are statistically significant, although the repeated measures ANOVA is. The SUS for ASL input among deaf users is 71.6, compared to a SUS of 63.7 in spoken English input for hearing users. Both Tap to Alexa and Apps with Alexa input usability are rated worse, with SUS scores falling below 63.7. Most participants express challenges in recalling the steps, stating that it takes them a while to get used to Tap to Alexa and Apps with Alexa. Tap to Alexa also forces participants to move closer to the Alexa device, which some find inconvenient. Furthermore, participants feel Apps with Alexa is less intuitive in comparison. While a SUS of 71.6 is better than average, it remains generally low and does not reach the threshold of truly good usability. This slide shows the post-experiment survey results. Figure 6 illustrates the participants' favorite input methods when interacting with IPAs like Alexa. When asked about their preferences, the majority of the participants strongly preferred ASL for interaction, consistent with ASL being their primary communication mode. More than half expressed willingness to explore alternatives like touchscreen typing or gestures. The importance of offering alternative input methods for IPA interfaces is emphasized. Figure 7 shows participants' indicated preferences for wake words and methods. The majority prefer eye gaze at the device, along with either signing a command or waving their hands in an attention-getting wave. Less than half preferred methods such as pressing a key, using the Alexa app, or tap to Alexa. The median vocabulary of participants is 41, with an additional 9 fingerspelled words. Gestures were also used, most commonly presenting as hand-waving to get the device's attention, or turning palms upward or outward, also known as palms up, to either denote the end of an action or react to something unexpected. The distribution of signs exhibit exceptionally long tails. 83 signs occurred only once across all participants. The word cloud shows the relative incidence of signs across participants while interacting with Alexa. Larger words occurred more often, and signs prefixed with FS and parentheses denote fingerspelled words. IX in purple represents pointing to a specific subject or object referent, and signs with an asterisk suffix are non-key signs, meaning that omitting them would not change the meaning of commands given. One of the most seen linguistic phenomena was fingerspelling, which is often but not exclusively used to identify titles and names. Conversely, we noticed participants using signs to refer to movie titles instead of fingerspelling them. Many participants gestured via an attention-getting wave to the camera, which occurred a total of 60 times. This is a culturally appropriate attention-getting technique within the deaf community. We had not instructed participants to use this attention-getting method, and the wizard stayed silent when encountering it. However, participants clearly were expecting it to function as an equivalent to using FX Alexa or Alexa's name sign, involving the letters A and X in a query motion, as the wake method. Our findings suggest that ASL to Alexa demonstrates as well as or better usability-wise compared to English voice input. The lack of substantial significance in the difference in usability scores suggests that touch-based input options do not clearly lose out over ASL. However, this could also be a result of the limited domain and constraints associated with the task lists. In the post-experiment survey, participants consistently indicated their preference for ASL input over the text-based alternatives. Several signs have potential for interpreter error. Participants are required to use an English-based wake word, and the addition of an interpreter adds to the lag time between the two main interlocutors. Future research should explore other and more culturally appropriate wake methods, as well as other limited domain applications like different rooms in a typical home and elsewhere, such as in a car. This experiment shows that users may be able to interact with IPAs within a constrained vocabulary system. For future work, interdisciplinary collaboration is crucial, integrating expertise in technology, accessibility, interpreting, ASL linguistics, all while addressing challenges, respecting cultural factors, and implementing standardized annotation systems is essential. This study does not prove preference for ASL input over touch, though it validates ASL as an input method with more research needed. Within our limited domain application, we can see that participants show an average of 41 signs, and slightly less than half of the signs produced are unnecessary for the technology to comprehend the command. There are several characteristics of ASL that haven't been looked at yet in relation to these interactions. For example, fingerspelling, interchanging fingerspelling and signing, numbers, eye gaze, indexing, and gesturing. Additionally, the English-based wake word method currently employed by personal assistant technologies should be revisited. More culturally appropriate wake methods, such as an attention-getting wave, should be considered.